So welcome to the last lecture of this chapter, that is chapter number 7, and this is the last lecture. In this lecture we will solve the remaining two questions from the exercise 7.4 and then this chapter will have been finished. Okay, so without wasting time, let's start with the first question of this lecture, that is question number 5 from the exercise 7.4. So according to the question, it is given in the following figure, right, PR is greater than PQ. So this side PR is greater than PQ. So let's write what is given here. It is given that PR side is greater than PQ side. Understood? Then PS is a line, right? PS is a line which bisects angle QPR. Okay. PS bisects which angle? QPR. That means this. So PS is called as angle bisector. What is an angle bisector? An angle bisector is a line which divides an angle into two equal halves. Since PS divides this angle, QPR angle, into two equal halves, that means this half is equal to this half. Understood? So you can write here PS is the angle bisector of what? QPR angle, or you can write this angle means QPS is equal to this half or this angle RPS. These are the two statements that is given. Now according to the statement, we have to prove that PSR, this angle is greater than PSQ, this angle. Okay, so to prove PSR is greater than PSQ, how we can prove it? Let us discuss. Okay, since it is given that PR side is greater than PQ side, isn't it? Since PR is greater than which side? PQ side. It is given. So it is for the triangle PQR. Okay. Since PR is greater than PQ, then what is the opposite angle of this side PR? Forget about PS. Don't think that there is a PS. Only consider PQR triangle. Okay. So what is the opposite angle of PR? This angle Q, or you can write angle PQS. Okay. Then what is the opposite angle of this side PQ? This angle. Okay. PRS. Okay. According to the theorem 7.6, we know if in a triangle any two sides are unequal, then the angle opposite to the larger side is larger. Since PR is the larger side, its opposite angle is this angle PQS, then it must be larger. Okay, do you understand it? Then we have found that PQS angle, this angle is greater than PRS, this angle. Done. Now we'll do what? Now in the left hand side, let us add this angle. Which angle? This angle. Means QPS. Similarly, in the right hand side, let us add the same thing. We know that if same thing is added, then there is no change in the final result from the chapter number 5 axiom. If same thing is added, okay, for example, if 5 and 5 are equal, if we add same thing, then the result is also same. Similarly, if we know 3 is greater than 2, right, if we add 1 here and 1 here, then the result is 4 and the result is 3, then also we have the same value. Here also 4 is greater than 3. For example, if 10 is greater than 9, then we add 5 here and 5 here, then the result is 15. Here the result is 14. Similarly, 15 is always greater than 14. So if we add the same thing in both LHS and RHS, then there is no change in the result. Similarly, what we have done here? Here we have added QPS angle, this angle, to left hand side and to right hand side. Okay. So let us write it. Adding QPS angle in LHS and RHS. Right. Okay. Then. So PQS plus QPS is greater than. Now write PRS plus. See, we know QPS angle, this angle is equal to this angle. We know it here. QPS is equal to RPS. So in the place of QPS we can substitute RPS. You have to write the reason. The reason is that QPS is equal to RPS. Why? Because PS is the angle bisector of QPR. So this angle is equal to this angle. Now it is understandable, right? So we have got PQS, that means this angle, plus QPS, this angle is greater than PRS, this angle, okay, plus RPS, this angle, right? Now consider the triangle PQS. Okay, which triangle? PQS. Okay. Now in PQS triangle, this angle is known as which angle? Exterior angle. Again. Let's see. For the triangle PQS, this angle is known as which angle? Exterior angle. And the exterior angle is equal to the sum of two interior opposite angle, isn't it? Yes. So here the exterior angle is PSR and the interior opposite angles are this angle and this angle. So this angle is equal to this angle, means PQS plus this angle QPS, isn't it? Is it correct? The exterior angle is equal to sum of two interior opposite angles. Okay, here, and you can see here I have written PQS, QPS. That means here in the left hand side I have written the sum of this angle plus this angle. So can I replace the sum of these two angles? H, PSR. Can I replace it? Yes, I can replace it because the exterior angle is equal to sum of two interior opposite angle. So in the place of PQS plus QPS, I can substitute the exterior angle H, PSR because I have written here. We know this. Done. Okay. Then, as you can see in the right hand side, we have PRS. Which one? PRS. This angle. Plus RPS. Okay, this angle. Now consider the triangle PSR. Which triangle? Triangle PSR. In triangle PSR, this angle is known as which type of angle? For the triangle, this one. Just look at my finger. This one, this angle. Then this angle is known as exterior angle. Okay. So PSQ is exterior angle. And the exterior angle is equal to sum of two interior opposite angle. So which one is the two interior opposite angle of this exterior angle? This angle plus this angle. Yes or no? This angle plus this angle. Okay. So this angle is PRS plus this angle means RPS. So the sum of these two interior opposite angle can be added to give the exterior angle PSQ. So in the place of PRS plus RPS, I can substitute PSQ. Yes, PSQ. Okay. So here there is a symbol like this. Okay, done. You understand this? Why I substitute this in the place of this and why I substitute this in the place of this? Because these two are the alternate interior or alternate opposite angle for this exterior angle, and these two are the alternate opposite angle for this exterior angle. Done. So what we have found here? We have found that PSR angle, PSR, this angle is greater than PSQ angle, this angle. Yes, we have to write the reason here also. Since PQS plus QPS is equal to PSR, that's why we have substituted, and PRS plus RPS is equal to PSQ. Okay, why? Because they are the exterior angle, and the exterior angle is equal to sum of two interior opposite angles. So finally we have found that PSR angle is greater than PSQ angle. Here we have proved the statement, proved, because we have to prove this. Where is? Yes, this PSR greater than PSQ. Understood? So now we have proved that this angle is greater than this angle, PSQ. Understood? So finally coming to the last question of this chapter, chapter number 7, that is question number 6. So let us understand the question. It is given that, so that means you have to prove that of all the line segment drawn from a given point to a line not on it. Understand the sentence here. All the line segments drawn from a given point. That means there is a given point. Let's say this is the given point. Let's say this is your A. Okay. So you have to draw line segment from a given point A. Okay. To whom? To a line. We have to draw different line segment from a given point A to another line. Okay. Not on it. It means, let's say this is the line. Okay. Let's say this is the line. Okay. Done. Now you have to take a point A which should not lie on it, not on it. It should not lie on this line segment. Okay. So this is a given point. Now from this given point we have to draw different line segments. Let's say this is a line segment to this line. Let's say this is another line segment. Let's say this is another line segment. And let's say this is another line segment. Okay. So we have drawn 4 line segments. Let's say this is your B, this is C point, this is D point, this is E point. Okay. Done. Now the perpendicular line segment. Okay. So out of the 4 line segment, you have to draw any one perpendicular line segment. Perpendicular line segment means you have to draw a line from the point A so that it makes 90 degree with the base this. Okay. Let's suppose this is the perpendicular line segment. That means it makes 90 degree with the base. Okay. You have completely understand the question. Similarly, you have to understand every question in the examination. Okay. So here we have drawn 4 line segment from a given point A to another line. Okay. And this point doesn't lie on this line. Now, out of the 4 line segment, let's say one line segment make an angle 90 degree with the base. Now we have to show that the perpendicular line segment is the shortest. How many line segments we have drawn here? We have drawn 4 line segments: AB, AC, AD, and AD. Similarly, you can draw infinite number of line segments. That doesn't matter. Okay, so you have to prove that out of such line segment, which one is the smallest? The line segment which makes 90 degree with the base is the smallest. This AB makes 90 degree with the base, but AC doesn't make 90 degree, AD doesn't make 90 degree, A doesn't make 90 degree. So the line segment which makes 90 degree with the base is the shortest. That means AB is always less than AC. AB is always less than AD. AB is always less than A. We have to prove this, that AB is the shortest among the 4 line segments. Okay, so let us prove it. No doubt, from the figure we can see, yes, AB is the shortest, but we have to prove it mathematically. How we can prove? So first write what is given here. What is given? AB, SC, AD, A are 4 line segments. Okay, done. And AB is perpendicular to this base. Suppose B. Perpendicular means this angle is 90 degree. Okay, or you can say implies ABC angle, or you can say ABD angle, or you can say ABE angle is 90 degree. Okay. To prove AB is the shortest side. AB is the shortest distance. So let's prove it. In order to prove it, we have to consider first triangle ABC. ABC is a triangle or not? ABC is a triangle. Yes, it is a triangle. So we will consider for triangle ABC. Okay. Now in the triangle ABC, this angle is 90 degree. Now it has another two angles, this angle and this angle. You know it. It has another two angles, this angle and this angle. Understood? And the sum of these two angles is equal to 90 degree. Then tell me whether this angle is greater than this angle or this angle is less than this angle. Tell me. Definitely I have told you that if it is 90 degree, then this angle must be less than 90 degree. Because if it is greater than 90 degree, then if we add these two, then we will get 181 degree, which is greater than 180 degree. We know the sum of the three angles of a triangle is 180 degree, but here it is greater than 181 degree. So it is impossible. So this angle can never be greater than this angle. Similarly, this angle can never be greater than this angle. Understood? So we can write that angle B is greater than this angle. Okay? So angle B is greater than which angle? Angle C. Right. Now, in the triangle ABC, which one is the opposite side of the angle B? This side, that means SC. Okay, SC. And which side is the opposite side of the angle C? This, that means AB. Now, according to the theorem 7.7, we know if in a triangle any two angles are unequal, then the opposite side of the larger angle is larger. Here, the opposite side of the larger angle is this is the angle B, this is the larger angle, then its opposite side is SC. So SC must be greater than B. Okay? Because B is the larger angle, so its opposite side must be longer. Due to theorem 7.7. Do you understand it? So what we have found? We have found among SC and AB. Among SC and AB. SC and AB are what? They are the line segment. AB and SC are the line segment. So among SC and AB, which one is shortest? AB is smaller. Okay. So you can write hence AB is smaller than SC. Clear? This is done. Next we will compare the triangle ABD. Which triangle? The triangle ABD. Okay. So for triangle ABD. Okay. So if we consider triangle ABD, then no doubt this angle is 90 degree. Okay. For the triangle ABD, the sides are AB, BD, AD, and this angle is 90 degree. And another angle is this angle and this angle. Understood? Forget about SC. Don't think there is SC. Only consider ABD triangle. Right? This angle is 90 degree. This is the another angle. This is another angle. So similarly, here also you can write that this angle is smaller than this angle, because this is 90 degree, then it must be less than 90 degree. Do you understand this? So B angle is the largest angle among the three angles. So you can write that angle B is greater than, angle B means you can write like this, angle ABC or angle B is greater than this angle. is greater than this angle. Simply you can write D. Here also simply you can write angle B. No problem. Okay. Now consider the triangle ABD. In ABD triangle, the two angles B and D are unequal. Now according to the theorem 7.7, we know if in a triangle two angles are unequal, then the opposite side of the larger angle is longer. Okay. So which one is the opposite side of the angle B? The opposite side is AD. And opposite side of angle D is AB. Okay. AB. Understood? So the opposite side of the longer or larger angle is longer. So here we found that AD is greater than AB. So here we have compared two line segments, AB and AD. AB and AD. And what we have found? We have found out of the two line segments AB and AD is the longer or larger. So AB is the smaller. So we can write that AB is smaller than AD. Okay. Next we will consider another triangle. That is which triangle? That is ABE. Which triangle? ABE. The largest triangle. Okay. So for triangle ABE, it has also three sides: AB, BE, A. Done. Next, this angle is 90 degree. Then for this triangle, this is another angle, the total angle, and this is another angle. Okay. Now since this angle is 90 degree, then we know the other two angles are added to give 90 degree. It means this angle must be less than this angle, and this angle must be less than this angle. So simply we can write that angle B is the largest angle among the three angles. So you can write angle B is greater than this angle. Angle B. Okay. Then find the opposite side of the angle B. Which one is the opposite side of angle B? This one. A. Which one is the opposite side of angle E? This one. Side AB. Understood? So according to the theorem 7.7, if in a triangle two angles are unequal, then the side opposite to the larger angle is longer. Understood? So what we have found here? We have found between AB line segment and A line segment. Which line segment is larger? A line segment is larger. Which is smaller? AB is smaller. So here we have found AB is smaller than A. Understood? Similarly, if you want, then you can draw another line segment like this, another line segment like here, another line segment like this. So every line segment here you found is always greater than this AB. Why? Because here we have found AB is smaller. That means AB is less than AC. Here we find AB is less than AD. Here we find AB is less than A. Similarly, any line segment you will draw, that you will find that all those line segments are greater than AB. It means AB is the smallest among all the line segments drawn from a given point to a line. Understood? So this is the last exercise of chapter number 7, and we have completed it. Okay.